Om Swastiastu, Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera bagi kita semua. Namo Buddhaya and salam harmony. In this change, me and my friend will explaining in-depth study of limit. But first, let us introduce myself. Let us introduce ourselves. My name is Putu Ananda Savitri. With you guys can call me Ananda. With my student number is 22151010057.
Hello, my complete name is Ivonia Fatima Viegas with the student's number of 22, 15, 10, and 85. And today I'm gonna explain to you about in-depth study of limits.
And now, in this material, if limit 1.2, we'll explaining about in-depth study of limit. We'll also explaining some of the example from the question from the limit module, and then from the limit other sorts.
And today I'm gonna explain about the in-depth study of limits. Before that, we have to know about the definition of non-standard. Limits fx equal to L, x to c, it means that the difference between fx and L can be made as small as possible by requiring that x is close enough but not equal to c. And also, in that study of limit, we have to know about the Greek letters. The Greek letters, it means that the letters from Unani that we have to know is that epsilon and delta. Here's the symbol, and these two letters is represent the small positive numbers that will represent all the small positive numbers. And here's represent the graphic. It is known that the difference between fx and L can be made as small as possible. Here's the graphic. This line represent the fx, and this line represent the x. L minus epsilon less than fx less than L plus epsilon equal to absolute fx minus L less than epsilon. And here we know that for fx to approach L, it requires that x must be close enough but not equal to c. Here's the graphic. See over here, from the left side c minus delta, and from the right side is c plus delta. c minus delta less than x less than c plus delta greater than absolute fx minus c less than delta. Here's we talk about the standard definition. Limits fx equal to L, x to c means that for epsilon greater than 0, it's given however small there is delta greater than 0 that match in such a way of mod of absolute fx minus L less than epsilon, provided that 0 less than x absolute x minus c less than delta greater than absolute fx minus L less than epsilon. Here are some examples from the module that could make us understand more about the in-depth study of limit. Here's the first question. Provide a piece of evidence epsilon minus delta of its fact of limit. The first question is limit 14x squared minus 20x plus 6 per x minus 1 equal 8, limit x to 1. By using the formula of in-depth study of limit, is it 0 less than x minus c less than delta greater than absolute fx minus L less than epsilon. By using this formula, we substitute. We already know the value of x minus c is it x minus 1, and fx absolute fx minus L, so we substitute with by using this equation for 14x squared minus 20x plus 6 per x minus 1 minus 8. We make this equation become a factorization. To make it into factorization, become this 2 times 7 x minus 3 times x minus 1 per x minus 1 minus a. This two is same, can make it like this and become like this 2 times 7x minus 3 minus 8, and we make it multiplication. 2 times 7 is 14 and x minus 11 from x minus 3 minus 8, and we make it separated, and x minus 11 less than epsilon per 14. Then we already know, we already choose the value of epsilon, is it the value of delta, is it epsilon per 14. Now prove that or buku bakunya adalah by using the form 0 less than x minus 1 less than delta greater than, by using this fx minus l, substitute with the equation 14x quadrat minus 20x plus 6 per x minus 1 minus 8. For each epsilon greater than 0, we already select the value of delta, is it epsilon per 14. So 0 less than x minus 1 less than delta, we can implicate like this 14 we can implicate like this 14 x quadrat minus 20x plus 6 per x minus 1 minus 8 less than epsilon. We make it like factorization, and after that we already know the value of 14, the value of epsilon, right? So we have to change 14 times epsilon, is it 14 epsilon per 14. So this one we can make it like this, and the value is epsilon. So we can make it, we can conclude that the equation of the 14, the equation of this 14 x quadrat minus 20x plus 6 per x minus 1 minus 8 less than epsilon, is it evidence?
Second question from the model, which find the proof of epsilon and delta from its limit fact of limit x to 1 is 10x cubed minus 26x squared plus 22x minus 9 of x minus 1 square equal 4. The first one, you need to like rewrite again the question and then find out that x less than x minus 1, that less than delta, equal 2 times 5x cubed minus 13x squared plus 11x minus 3 of x minus 1 square minus 4 less than epsilon. Find out that x is not same as 1. We can like break down the factorization from the numerators and find out that 2 times x minus 1 times 5x squared minus 8x plus 3 of x minus 1 square minus 4 less than epsilon. Eliminate the x minus 1 equal 2 times 5x squared minus 8x plus 3 of x minus 1 minus 4 And then we can break down the numerators again into 2 times 5x minus 3 times x minus 1 of x minus 1 minus 4. Again, eliminate the x min 1 and equal 2 times with 5x minus 3 minus 4. We can mix the minus 3 and minus 4 equal 10x. The first we need to times the 2 and then becoming 10x minus 6 minus 4 less than epsilon. Break down again and became 10 times x minus 1. So x minus 1 less than epsilon of 10. And then find the epsilon, same like before, until the 10 times x minus 1 change the epsilon, becoming 10 delta equal epsilon. So 10 times x minus 1 equal x minus 1 lesser than 10 delta equal epsilon.
Here's another examples. Limits 3x minus 7 equal 5, limit x to 4. By using the formula of in-depth study of limit 0 less than x minus c less than delta greater than absolute of x minus l less than epsilon. First of all, we have to analyze or make it like orat. 0, by using this formula, we substitute with the equation 0 less than x minus 4 less than delta greater than absolute 3x minus 7 minus 5 less than epsilon. Make it together. 3x minus 7 minus 5 less than epsilon. It's 3x minus 12 less than epsilon. Make it into factorization. 3 times x minus 4 less than delta. Make it separated. 3 absolute 3 and absolute x minus 4 less than epsilon. And the value of x minus 4 is less than epsilon per 3. So we have the one that we choose for the delta is it epsilon per 3. Row proof. Now we prove that 0 less than x minus 4 less than delta greater than 3x minus 7 minus 5 less than epsilon. For each epsilon greater than 0, we select delta is epsilon per 3. Is epsilon per 3 here. So 0 less than x minus 4 less than delta, we can implicate like this. Become this. Absolute 3x minus 7 minus 5 less than delta. Epsilon, sorry. 3x, make it more smaller. 3x minus 12 less than epsilon. Make it factorization like this and become like this. So we already know the value of epsilon is it 3 times, we change it, or yeah, we change it, this with this value is 3 times epsilon per 3 is become like, or the value is epsilon. So we can conclude that the value of 3x minus 7 minus 5 less than epsilon is evidence, or is it true? Okay.
Second question from the other source. Prove a proof of epsilon and delta from its limit fact of limit x to 0 2x minus 1 equal minus 1. So in delta, write again the question for finding the delta and then find out that 0 lesser than x minus 0 lesser than delta equal 2x minus 1 lesser minus negative 1 lesser than epsilon. It equal to 2x minus 1 plus 1 lesser than epsilon. So 2x lesser than epsilon, which means 2 times x lesser than epsilon. So we can find out that x lesser than epsilon of 2. We can find out that delta is epsilon of 2. And then finding out that epsilon, after we find out that x, that delta is epsilon of 2, so we can find out that x lesser than 2 epsilon. So 1 epsilon is equal, so 2 times x equal epsilon is same as x lesser than epsilon than 2 delta equal an epsilon. So we can interpret the value of epsilon of 2 delta equal to epsilon is evident. So that's all about the limit 1 to 1.2. I hope you guys can understand about it, and we are really sorry if there's any material that you guys cannot understand about it. For the next video, we'll explaining about limit 1.3. Keep waiting, and thank you for your attention. We're closing this video with Pranama Santi. Om Santi 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 Om. Wassalamualaikum warahmatullahi wabarakatuh. Salam sejahtera bagi kita semua. Namo Buddhaya and salam harmony. See you to the next video. Bye bye.